Good morning, students. I hope all of you understood the first 6 questions from the exercise 8.2. So now here only one question left, and which one is question number 7. As you see, the question is given here. ABC is a triangle, right angle at C. A line through the midpoint M of hypotenuse AB and parallel to BC intersects AC at D, and we need to prove here. First one is D is the midpoint of AC. Second one is MD perpendicular to AC, and the third one is CM is equal with MA, or we can say AM equal to half of AB. These three we need to prove here. Is it clear? Okay, now let's start here. Let's see how can we prove this one. For this, first of all, here we need the construction, and the construction part is here. First of all, a triangle ABC we have to consider, so that's why here we draw a triangle A, B and C. Is it clear? As you see, the question is given right angle at C. So that means this C angle is here 90 degree. Is it clear? So that means here this C angle is here how much? 90 degree. So now here, after that, a line through the midpoint M. So that's why here written, if you see, M is the midpoint. M is the midpoint of AB. And line through M, through this M we have to draw a line. Is it clear? And parallel to this line, whatever we draw, this line is always parallel to BC. Is it clear? And when we draw a line through M, this line intersect AC at D. Is it clear? So that's why here we mention D. So now here, first of all, first one, what we need to prove? The first one we need to prove this D is the midpoint of AC. So very simple question here. First of all, as you see here written, in triangle ABC, M is the midpoint, isn't it? M is the midpoint of AB already given. So when we draw a line through M parallel to BC, already mentioned, and intersect at D, so that's why easily we can write here MD is parallel to BC, isn't it? Because it is given to us. So now here, when MD is parallel to BC and M is the midpoint, so one converse theorem we know, converse of midpoint theorem, isn't it? Through the converse of midpoint theorem we know this D is also the midpoint of AC. Why? Because already one point is midpoint and this line is parallel to BC, and according to our converse of midpoint theorem, easily we can say D is the midpoint of this side, third side, isn't it? So this one already we know. So here first one is we need to prove D is the midpoint of AC, which one is complete here. Is it clear? Okay. Now after that, now the second one, if you see, so second one we need to prove this MD is perpendicular to AC. Where is MD? So this one is the MD, and we need to prove MD is perpendicular on AC. That means perpendicular means we know if this angle, any one angle, either we write MDC or we write MDA, if any one angle is here, if we prove 90 degree, that means this MD is perpendicular on AC, easily we can prove. Isn't it? Okay, now let's see here how can we do this one. So already we know this DM is parallel to CB, or we can write BC parallel to MD also we can write, as you know. So now here this DM is parallel to CB, as well as this line, whatever we draw, this AC we consider as a transversal, isn't it? Because DM and BC are parallel, so easily we can say this line is AC is what? Transversal line, isn't it? So if AC is the transversal line, so easily we can say here MDC or DCB. That means MDC means here MDC. That means this inter-angle as well as this inter-angle. And these two are also we can say co-inter-angles. So these two angles, the sum of these two angles is how much? We know 180 degree. Isn't it? Because AC is what? Transversal and DM and CB are parallel. So that's why the sum of these two angles is how much? 180 degree. So that's why as you see here written MDC plus DCB. The sum of these two angles is how much? 180 degree. And if we keep this MDC and already we know the angle DCB. This angle is already mentioned right angle. That means how much? 90 degree. So in place of DCB we put 90 degree as you see here. So 90 degree when we put, and if we calculate this one, then angle MDC equal to how much we get here? 90 degree. So MDC equal to 90 degree means what? MD is perpendicular on AC. Is it clear? Understood or not? So easily we can say here MD is perpendicular on AC. So this one is our second proof. Now in the third one, if you see the third one, in case of third one, CM equal to MA equal to half of AB we need to prove. So for this here, what we need? According to our question, CM we need. So for CM, what you have to do? We have to join this one. So in the third part, a little bit construction is here. Now let's see. Now, after joining this CM, because here we need to prove CM equal to MA equal to half of AB. So that's why we join now CM. Is it clear? So after joining CM, if you see here, two triangles are we get. If you see the triangles, first triangle is here, we can say here AMD. One triangle is this one and another triangle is here CMD. This one is another triangle. Is it clear? Two triangles are we get here. So if we consider these two triangles, one is AMD, another one is CMD. So in these two triangles, first one we write AD equal to CD. Reason behind, D is the midpoint. If D is the midpoint, the length of AD and CD are equal, isn't it? So that's why this one we write first, AD equal to CD as you see here written. After that, next one is you see here ADM. This angle is how much? 90 degree. So obviously CDM is also how much? 90 degree. So here we write here ADM is equal with CDM, isn't it? And the third one is you see here in both triangles, in triangle AMD and CMD, in both triangles DM is what? This DM is common, isn't it? So now here first CD equal with AD we get, isn't it? And secondly this angle is equal we get, side angle, and the third one is here, this one is side. So which congruence rule we can apply here? Side angle side. So side angle side congruence rule we have to apply, and then we write here AMD congruent to CMD. Is it clear? By side angle side congruence rule we can say these two triangles are congruent. If two triangles are congruent, then that means what? Their corresponding parts are also equal. So corresponding parts are also equal means easily we can say here in these two triangle, this AM is equal with CM. Is it clear? So that's why we write here AM equal to CM by CPCT. Is it clear? Okay. Now after that, again if we repeat here, you see AM is what? AM or BM? M is the midpoint or not? If M is the midpoint, so that means easily we can say the length of AM is equal to half of AB. Isn't it? Since M is the midpoint, so that's why the length of AM is equal to half of AB, the whole length. And already we prove AM means what? AM means CM. Is it clear? So that means from here we can say here in place of AM also we can write CM. So from here easily we can say the length of CM is equal with length of AM or MA, whatever you write, and this whole length is equal with half of AB. Is it clear? Understood or not? I repeat this one. You see, M is the midpoint. So if M is the midpoint, the length of AM is equal to half of AB. And in place of AM also we can write CM. By CPCT already we proved. So ultimately what we write here, CM equal to half of AB. So that means here our third one is also complete. Is it clear? I hope all of you understood this one also. So now here from the exercise 8.2, total 7 questions are there and all questions are we complete. So the quadrilateral chapter is over here. So exercise 8.1 and 8.2 including all the theorems here we discussed. So I hope all of you understood this one. So in our next class we have to continue with another chapter. Is it clear? Okay, thank you.